Hello everyone. Today I am going to discuss the last problem of Leetcode Biweekly contest 155, which is maximum profit from valid topological order in a DAG. So what is the problem? We are given a directed acyclic graph or DAG with n vertices level from 0 to n minus 1, and we must process the nodes in a valid topological order. So what is the topological order? I will explain next. Now the profit is calculated by summing up the product of each node score and its position in the ordering. Okay, we have to return the maximum possible achievable profit with optimal topological ordering. So what is the topological ordering? Let me explain you first. So let's take the second example. So this is a tag 0 to 1 and 0 to 2. So this means that 0 to 1, that means that 1 is dependent on 0, and similarly 2 is dependent on 0. So we have to process 0 before 1 or 2. So one valid topological ordering is 0, 1, 2. Okay, because we have processed 0 before 1 and 2. Another possible topological ordering will be 0 to 1. Okay, so what will be the score for maximum profit? What will be the profit for the first ordering 0, 1, 2? So score is 163. Let me write it. Score is 163. 163. So for the first ordering, we will get 0 index. So we will get 1 plus 1 into 1 plus 6 into 2, because this will be at the second position. 1 will be at the second position, so we will get 6 into 2 plus 2 into 3. Okay, so this will be for the first case, first ordering. For the second ordering, the score will be 1 into 1 plus uh, 1 is at the third position, so we'll get 6 into 3, and 2 is at the second position, so we'll get 2 into 2. So the score for the first ordering is 6 plus 12, 18 plus 2, 20, sorry, 19, 18 plus 1, 19. And for the second ordering, it is 4 plus 18, 23. Okay, so the most optimal ordering is 0 to 1, right? So answer will be 0 to 1. Okay, and I think what I have missed, 18 plus, oh, this is 23, right? So it will be 25, not 23. Okay, so 2 into 3, and this will be 2 into 3 and 3 into 3. Okay, this will be 3 into 3. So 9 plus 12, 21, this will be 22. Okay, 22 and 25, and the optimal is this one, second one. Okay, I hope you get it. So that's why our answer is 25, right? So how we are going to solve this problem? Okay, so there are multiple approaches to find topological ordering. One is DFS based approach, and another one is BFS based approach, which is called Kant's algorithm. Kant's algorithm, you can check that out. But in our case, I first when I look at the problem first, I thought that we can modify the Kant's algorithm, the BFS approach. Kant's algorithm is a BFS approach. I thought that we might modify this Kant's algorithm and get the desired answer. But then uh, I did not really dive into this approach. I am not sure how we can solve this problem using that approach. But before that, I have looked at the constants. So here you can see that constants on n is 22 only. Okay, so constants on n is 22 only. So when the constants on n is that low, okay, so in that case, this is not right for solving the problem in normal setting. But in a contest setting, you have to look at the constants, right? So whenever I looked at the constants, I thought about that n is small, so we can think about bit masking. Okay, I, we might think about bit masking. So there might be more optimal approach than this. I'm not sure, but bit masking will be a possible solution that came to my mind because of the constant. Because bit masking will be 2 to the power n, and 2 to the power 22 is less than around 10 to the power 6, right? So 2 to the power n bit masking solution will help us. So how I have solved this problem using bit masking, I'll explain to you. So I have used dynamic programming plus bit masking. Okay, so let's say I have a mask state. Okay, mask state means visited state. Okay, I have visited state. So let's say we have 3 nodes. Okay, so in the 3 nodes we have, in the bit mask we have 3 zeros. Okay, so whenever we have visited the first node, okay, 0th node, then we'll mark this bit as 1. We have set this bit as 1. So we have visited first 0th node. Okay, 0th node. If we have visited the 0th node, then we mark the 0th index as 1. And then we have let's say visited the second node, then we'll mark this node second index as 1. So 101, like that. Now let's say we are at some state recursion of a mask. Okay, now can we mark the ith state? We can only mark the ith state. Okay, let's take this example. Let's say we want to mark the second state, second index. Okay, we can only mark the second index if, let's say, it is dependent on another index 3. So we can only mark the second index if the 0 and the third index is already set in the mask. If the 0th and third index is already set in the mask, then only we can mark the second index. Okay, so that's why I have already also taken one dependent I. Okay, dependent I means I is dependent on which index. So dependent I is another mask, bit mask. Dependent I is another bit mask. So here you can see that 2 is dependent on 0 and 3. So we can say that dependent of 2 is nothing but 2 to the power 0 plus 2 to the power 3. So this will be dependent of 3 will be 9. So we will check that if the dependent of 2 is a subset. If dependent of 2 is a subset of the current mask, then only we can take 2. Okay, so let's say our dependent of 2 is 1001. Okay, third bit is set and the 0th bit is set. Okay, now let's say our mask is 1010. Okay, so this 1010, this mask, this dependent of 2 is not a subset of this. Okay, so we can't really mark the second index. But let's say our mask is 1011. 1011 is a subset of this, right? 101. This is a subset of 1011, so we can take 2 in that case. So let's jump into the code. We'll understand it better. Okay. So overall time complexity is 2 to the power n, right? 2 to the power n into n. Okay. 2 to the power n into n. So what I have done, this is the recursion function. So I have checked if the mask is 2 to the power n minus 1. That means all the nodes are visited. We will return 0. If it is memorization, if the current mask state is visited, we will return DP mask. Okay. Now index means that number of let's say here we are multiplying, right? Here we are multiplying by 2. Whenever we are multiplying by 2, that means that one bit is set in the mask. If one bit is set in mask, then the next index will be 2. That's why get count of mask plus 1 will be our next index. Get count gives us the number of set bits in mask. Okay, so get count mask plus 1. Okay, now we'll check for every index 0 to n. We'll try to set the index I in the mask. So it will check if the mask has not, this means that the mask did not have the ith bit set. So this means that mask did not have the ith bit set, and this means that the dependent of I is a subset of mask. Okay, the dependent of I and mask is dependent of I. Okay, so let's say I have in the example we have this as mask and this as our dependent of I. So if we take the n between these two, then the value should come as our dependent of I. Okay, the value should come out as our dependent of I. So these two conditions are satisfied. We can set this index to the mask plus 1 left shift I. That means that we are setting this ith index in the mask, and the answer will be updated by score I into index. Okay, I hope you get it. At the end we are returning DP of mask. Okay, so here this is the initialization part, and here for every age I am marking age the dependent of age 1 with age 0. So in the dependent of age 1 we are setting the age 0 bit as set. Okay, I hope you get the explanation. The problem is quite interesting. I will provide the link of the code in the description box. If you have any doubt in any part of the code or explanation, you can always ask in the comment section. I'll try to reply each and every comment. If you find this video helpful, please like the video, subscribe to the channel, and also share among your peers. Thank you.